class is so like there are these guys, the people, Michael's friends. One time Michael's friends walked into that class and they're like, he's such a pathological liar.
I'm surprised they didn't fully turn it upside down.
Dude, that math class was insane. And Graham went to Fogarty after all and was like, you're a massive dickhead. Do you know that?
What?
Graham said that to Fogarty's face.
How does he know? He's only been to 2 of his classes.
I don't know. No, but the only reason Fogarty went to today's class was because he's office hours talking shit to Fogarty. And that's the only reason.
In what way? Why is he so personal about it?
I don't know. Dude, that math class is the most fun math class in the world. When is that dude gonna die? Like, not like it's mean. I'm sorry about it.
I don't know how to respond.
Yeah.
What's mute did you get? Maybe it was 0.97.
Really?
Yeah.
Oh, that's good.
She got 7.
I don't. Okay, to be fair, I didn't do a single calculation.
All right, guys, welcome to this is Wednesday, the 23rd. Yeah. Looks like we beat the weather for today. Lab 2, or should I say Tuesdays for Lab 4? How did it go for you guys? Yes. Okay. We're kind of understanding the picture of differential leveling.
Yeah.
Okay, so going forward, I did talk to some of you guys, and it did help with the feedback. You know, I never taught this class. I've only done the last side of it, so it was always, I could always just tell you exactly what we're going to do, and then we were just going to go do it. I mean, 5 minutes away from what we were going to do, so, but being that we were a week and a half out or 2 weeks out, and I'm telling you guys this differential leveling or profile leveling, and you can't even see it. I think I will use a little bit more visual aid going forward with the instruments here in lecture and see how that works. But for today, I kind of want to ask you guys, who's good at foreshadowing? Intuition.
Nothing.
If I were to say today's the middle of the week, in the middle of the term.
Oh, test.
Yeah, midterm. All right, bro. Not today. Not today.
Midterm.
Not today. But I do want to make the announcement. I'm not gonna make a surprise midterm. No, I'm not gonna do that to you guys. But I will let you guys know that there is a take-home exam on your Canvas. All right, it is available until the 2nd, which that is the due date on there. All right, so again, it's there for you guys. It should cover everything we've done up to so far, and nothing past, I would say, homework 3 with differential leveling, right? Homework 3 with differential leveling. What was homework 4? That was the traverse, right? Yeah, so nothing on traversing. Don't worry about that. So again, you guys want to go over any of that subject that you don't feel comfortable with, we can today. Otherwise, we can just push forward and start going into traversing or just going into that spirit. But if you guys want to go over anything at all that concerns you, but again, the take-home test is open book, it's open notes. So you can reference anything that you have, anything that's on Canvas for yourself, right? So again, if you want to go over it today, we can. Otherwise, we can just move forward and go to Travers.
Just give the midterm in class.
No, we're not going to give the midterm in class. I'm not going to make it.
Is there a time limit for an exam?
You don't have a time limit. You do have one upload limit. I give it to you one time. Right? So get your stuff in. You like it, and upload it. Once it's uploaded, it's uploaded. Get it one time.
But you know, like roughly how long it should be? It's like a couple.
So 20 questions. It's 20 questions. There's about, I would say, 6, maybe 7 if I counted correctly. Math type of, convert or Sakatoa type of thing. And the other ones are multiple choice. Yeah. So there's those. Anything else? All good? We're okay?
You're not going to look at question 2?
What's that?
Question 2?
Question 2? What's question 2?
Oh, I was just curious about it.
We're
If you won't go through it, then.
Are you talking, homework 2? No? Exam 1, question 2, is that what you're asking?
Yeah.
Oh, okay. That's, okay. So it's the PDF,
But
right?
if you can't go through it, that's fine.
So are you talking about convert angular measurements? That one?
No, that's easy.
Okay. Which question 2 then?
That was the other.
What other thing?
Okay.
Okay. Okay. All right, cool.
Wait, so that's
I'm
our-
already
that's our-
lost.
That's your text. I'm giving it to you right now. So you're gonna think I'm a nice guy. Well, yeah, but you think I'm a nice guy, and then I'm gonna give you Big Sam 2, and I'm gonna make you do a whole Traverse adjustment with compass rule adjustments. And you're gonna hate me. So I'm being nice right now. But later on in the term, we're gonna work through a whole Traverse adjustment.
You're lucky I don't know what that means.
As I'm explaining it to you right now, we are gonna be doing this in lab and running through these. But I am gonna make you do it in a test, in person, and see where you guys get to, right? And then we'll see how much you like me giving you this right there, right? So again, available here right now for you guys. You got it a second.
Can you? Yeah, I
You
Well, actually, I think my computer's
got your phone too, right? You got cameras on there?
Yeah.
There you go. All right. So you guys are okay? Again, I did change the due date for homework 4. Homework 4 is not due to the 1st, okay? Because we haven't even gone over any of the material yet. No, I haven't changed those dates. I post them. They're not even available for you guys yet. So, I mean, they're not even really available, but we just keep pushing them along. It's tentative. I keep changing as I go. I'm not making it huge at that moment. I just post them. I put a date on there just so they can get reposted. I can go change that later. It's kind of just as the term is going and how flexible or fluid we can be with it.
So do you want us to look at homework 4 first, or
No, homework 4 has nothing to do with exam.
He gave me 10
Yeah, they're
points for this.
two separate things. Don't even look at
He
homework 4
gave
yet.
me 10 points.
0.6. Weren't you trying to do like 2?
So we're doing okay?
So can we do like for the, use like the engineering paper for the drawing and then like multiple choice, like do like what we did for the first homework? Like do a, or do we want it all on engineering?
Just do it all on engineering paper. If you can fit it all on the exam too, you can do it on. But if you can't, you can't. Again, I'll leave it up to you how you guys want to do it. Again, it's a take home one, right? A little more harder. Not harder, it's a little easier for you guys to decide. Anything else? Nothing? So let's get into Traverse adjustments, right? So today's topic of the day, which we will start going over in lab next week. So did everybody get through the computing of the bearings okay? Those that wanted to do the extra credit? Are you guys still okay with leaving it as is? I was just gonna give you guys to the end of the week.
For what?
You already turned it in, Gina.
Yeah.
Big go getter.
Damn, people are savage today. You know,
I guess it's the range. People on it.
people are just aggressive.
All right, guys. So let's just go over what kind of different traverses we have. What we'll have, have you guys looked at any of the notes going forward on this week? So what I kind of want to do,
I'm sorry, I actually have a question.
Yeah, sure.
Did you go over what adjusted elevation is? Again?
Adjusted elevation.
I'm
So
pretty sure that's pretty simple.
adjusted elevation. Let's go back.
I don't.
That's not bad.
Well, I still do it. And you don't.
All right. So are you asking for what is the adjusted elevation here?
Yes.
Okay. Let's go over that portion.
Preferably with those numbers.
Preferably with those numbers. How about I just give you a quick example on a different sheet here. Let's see. Do I have that with me? I don't.
Oh, okay.
Yeah.
I was about to say. You're good.
I don't. I have to wake up early
For honors. Nerds.
I just curl my shell. Now curl my shell.
What if I went to your honors class?
You can't. Hey, bro, two of my lecture notes are stuck because they're asphalt. Dude, want to hear it? Ah, bro, I showed it to Graham and he was like, I don't want to know why your notes are sticky. Bro, what's that?
All right, so here's an example that we had previously. So again, you ran through your elevations, right? So we had started on our known benchmark. And again, we're now comfortable, now that we've done the lab, kind of understanding how the notes are laid out, right? And so again, you started on your known benchmark 1. When you close on benchmark 1 again, you were 100 high, right? Understood there? Okay, good. So again, you take the summation of your back sites, the summation of your force sites there. Again, you came up with the same result of being 100 high, right? So again, you know that you're still in good standing with class 3, 2, and 1. But now, in order to make that adjustment, if we needed to make an adjustment, we were in a critical project, let's say like the Kingsley Field Air Base, where we have to be thousands every single time, otherwise the concrete boys don't get paid a $100,000 check, right? So we got to make sure that we are delivering that money. So what we do is we take the 0.04, like on here, or should I say, well, why would be 0.04? Should be 0.01. So we have the adjustment of negative 0.4. Oh, the constant, sorry. 0.4 divided by the n number of setups, and they give you this. So what would it be then? It would be.
What was the constant from?
Where'd that come from?
The class 2?
Class 2. No, this shouldn't be here. I'm trying to figure out where did that come from. If adjustment is needed, class 4. There's no class 4. I know. Where'd that come from though?
Is it because you have 4 turning points?
I have 4 turning points, but that's my n. It should be just 0.01.
Yeah, that's something over that.
It should be 0.01 there. Right?
So you just take your error divided by a number of setups?
So again, this should be, again, the error, or whatever it is, 0.01 divided by the number of setups, right? And that's not going to be 0.6, it's going to be 0.01. Right there. Okay, and then you apply that to every single one of these. So again, it's this, it would be here, this results added to your adjustment, right? And then you just apply that all the way down individually. That makes sense. But again, since we're working with 2,000ths of a foot, you can't really apply that. That makes sense. Again, if this number was higher, right? We made that like a 0.03 or a 0.04.
Don't you want to subtract it?
We do, but because we already have it in negative terms.
Oh, okay.
It's already negative there.
It should be negative.
Yeah, it should be negative. If you're higher, right? It should be, your value here should be negative because it needs to go down. If you were lower, if this was 0.9 or 99.98, you're low, right? And you need to increase your adjustment for every single one of those. Make sense?
So it's the final elevation minus initial elevation.
Yes. So let's just, for example, let's just make this one, right? Let's make this part 0.02 or whatever. Let's say this was all 0.03, and then again, you got to redo it there. But now this constant, right, is 0.03. So again, still the number of setups. So then this is again 0.03. And again, it's still pretty good because you're displaying that 5,000ths now, right? Again, it's still 5,000, but again, we can increase that to be huge. And you'll see that elevation change for every single one of those. So I can go up with it. Just let's say you guys are very terrible at this. And you get,
Damn.
well, you were. I mean, you were. How many?
He's kind of.
Raise your hand if you busted by 2 feet your first time.
Hey.
There you go. All right. You are terrible at this because it's your first time. It's not a bad thing.
I got 4.
It's your first time. I'll tell you this. My spring term, we did a level look around whole campus and we busted by 8 feet. It was terrible. Right? We had to redo it again, starting all the way from Ager, all the way around campus, all the way back to Ager. And somehow we finally closed, but the first time it was 8 feet. All right. So again, that's where we are on that. So again, you take that adjusted error, and now, right, that's what you're going to use that to get the new formula there. So that's going to be here. All right. So again, that's your adjusted error there, or your adjusted elevation.
So you're just tracking 97.33 from 0.02.
Yes.
Or I guess you take error.
You're either subtracting or adding, depending on if you were low or high here, right? At the closing elevation. If this was 0.103, right? You know that you're higher than your starting, so you need to adjust your elevations. Correct? Yeah. Because you're higher, right? If you started at if you started here, came back around and you ended up here, your values need to come down to meet down here. Right? And again, same thing. You start here, you go all the way around, and you just end up here. You need to bring your values up so you meet here, right? So that is the adjusted part of the elevations. Okay there? All right. Is there anything else for that part of the exam? Or exam 1, should I say? All right. So back to just laying out traverses and the different types. Basic traverse. So usually, kind of like what we were showing before with our interior angles and computing the azimuth, we have 2 bases of bearing. We're coming off of something. Okay, it's exactly the same as that. But in this example, we're going to use an azimuth or a benchmark called AZMK, right? And that's our known or control point. So let me type up a quick legend for you guys, right? So we have the triangle is our control points, right? They have known coordinates, known elevation to them. We'll make in a circle, a traverse station, something that you or your crew set for your traverse. Then we'll make the symbol for the measured angle. And we'll just do what we have a line with 2 lines down the middle of it, and that's our measured distance. Okay. This is our okay. So there's a couple different ways, or a couple different ways to do a traverse, and then there's one that we just don't do. I'll show you all 3. So we'll have first one we'll have here is a geometrically closed and mathematically closed one. Sketch here. We're gonna have our control point. We're gonna call this one AZMK. Okay. We'll have our first, and our next one, our next control point down here is just station A. All right, and then we're gonna run counterclockwise with this traverse. Again, here's our measured distance. Here's our traverse station. We have B there. Measured distance, our traverse station C. Right, and again, this is what we're coming from our bases of bearing. Right, at this location. C to D. G here, and then back to A. All right, so again, we're going to start at A, and then we're going to turn right, and we're going to measure the interior angle for this, right? Hit that one. So again, this is what we have, a geometrically closed traverse, where you're going to start backside here. You're going to set your instrument here, and you backside this control point, and then you turn your angles interior and measure all the way through.
So since all of them are two dashed lines, does that mean they're equidistant?
No. That's just this.
These
So
are measured.
if you look just at the legend that we created, we said that this line with the two lines is like the measured distance. So we have the angle, the interior angle, and we also have the measured distance. All right, what we have. All right, so this is just a general sketch of what a traverse would look like, geometrically closed and mathematically closed. So now, that is the standard practice. That's a standard survey or a standard traverse. That's basically the most common industry way of doing it. The second method is what we call a geometrically open but mathematically closed. All right. So again, another sketch for you guys. Go. So for this example, let's say we have our control point, one of our starting control points called AZ and K1 down here. All right. We're going to go traverse to this direction. And that's going to be another control point, and that's going to be control point, and that's going to be A. And then we're going to go here to B. And that's going to be a traverse point there. We're going to take a steep angle this way. It's going to be another traverse to C. I'm using the wrong location. Move these. Yeah. Good. Move these on the inside. We go here. We got D to there. Again, another traverse point. And then we end up, what we end on is two known control points. And we'll call this one E. and we'll tie into a second one over here. We'll call this one AZ MK2. All right. So for again, this example, you start over A, right? You're backsighting AZ MK1, and this time, what we're doing is taking the exterior angles when we're turning right. To become this would be the exterior portion here. That would be that one. For this class, this is just your example, but we will not really work with any of these ones. This is kind of once trying to understand the concept of these ones is going to be, well, trying to understand the concept of the other examples hard enough. I'm not going to try to throw this at you guys either, this course.
Is the reason why it's mathematically closed because you're starting and ending at the control points? So you
Yes, so you have you're starting at known control points and you're ending at known control points.
Okay.
So you're starting at published NGS points or maybe public records monuments that another surveyor has published, and you are closing on other published monument, and that's how we can say it's geometrically open because it doesn't close back on itself, but it is mathematically closed because we have coordinates for that.
Why would we use this method?
So this method would be used a lot for like pipe work.
Okay.
So a good example, I guess. Here's a good example for what I'll pull it up on Google Maps. So how many guys do you live on El Dorado there? El Dorado Street. I'm not trying to find your house. I don't care where you live. I don't need to go to your house. I just want to give you an example of what you see there. So if you look at El Dorado aerial view, you can tell that no longer looks like that on the street view, right? If you drive down El Dorado, that no longer looks like this, where we have sidewalk here, 2-lane, and a bike lane on one side, right? So if you go down El Dorado, I think they updated the map with it. It looks something, hopefully they did. No, they didn't. Awesome. So anyways, if you go down El Dorado, you will notice that there is sidewalk now, both sides. There's closures, and you can't park on the side streets through here, right? It's just a narrow lanes with bike lanes on both sides, and you have sidewalks on both sides. So this job or this project was for me to do what we call a topographic survey, starting on this side of El Dorado at this intersection here of Dahlia and El Dorado, and go all the way down right away to right away, all the way down here to not Van Ness, but to Lowell, right? So again, that was my summer project. Actually, sorry, wait, I got ahead of myself. Van Ness, because I had to get this portion here. So that was my summer project one summer. Well, actually, and then it was to topo the whole thing. But in order to traverse or get my angles correct, I had to come up with my own my geometric open traverse and a mathematically closed one. So I had to give myself 2 control points at the start with via GNSS GPS, go there, and end down here with another 2 on this side of the location. So I had an opened geometric traverse, but a mathematically closed one, because I was coming back to 2 known control points on this side, right? That makes sense? Trevor, you're looking a little
I'm just wondering why. I mean, if you have a control point, if you can find it just by GNSS,
right?
why not just do that the whole way?
No, because you got trees, you have buildings. The efficiency of GNSS compared to total stations is 2 different things too. Cost wise too. So there's a whole lot of different factors other than just GPS. It sounds great, but you need just a whole open range without any type of interference from anything.
Okay.
Whereas this here, it's a whole different ballgame. Yeah. Again, The other reason I would just use total time, where I'm using total station throughout this whole thing, because it's a little bit more accurate than satellite receivers, give me half-inch tolerances, but my total station gives me 1/8 of an inch to a 1/16 inch. All right, so the accuracy is a whole lot more with the total station. But anyways, so there's an example there, right? And again, this is in the previous or past lives. What helped was railroads, right? Highways, all that stuff. So again, that is one example of that, right? I start with 2 known coordinates or 2 known control points, do my traverse, and end on 2 known control points or 1 known control point, either way.
Are those supposed to be measured or are they not measured?
Everything's measured, yeah, I'm sorry. Measured distances as well, yeah. Again, we have measured distances through here. Right. And again, one way to, start working with this is by using, or with this example, we could use lat and departures, right? Example, traverse. We use latitude and departure formula, right? Or we take the distance times the cosine of the angle to get your coordinate, right? To apply it to your coordinate. You guys remember when we went over that in lab 3, right? The bearing stuff. So again, this is where we can use latitude and departure to get our coordinates for every single one of these traverse station points, or to compare the known coordinate point with our traverse, right? Compare the differences. Okay. So again, Friday, we're going to start working with, I want to see, well, let's see, let's pull it up over here on this guy here, on my modules. So I'm going to pull up this week 5 field, or sorry, week 4 field notes. And this is a good example of a small traverse, right? And this was done by, I believe, Professor Marker went out here and did this one a couple years back, and just kind of went out through and recorded some notes. And we're going to use this field data and what it's written on there. We'll use this as the example, and we'll work through this traverse of how to calculate the azimuths / directions. We can calculate the adjusted coordinates, the adjusted latitudes, the adjusted departure, right? And everything that you see here, you're gonna look at all these steps and all what we're doing is gonna be overwhelming. But when you start to just slowly take it as chunks at a time, you can break it down that way you can understand the method. Right? But that is the upcoming for Friday on the traverse stuff. Yep, Justin.
Are we gonna walk through how to like put it into the table and everything too? Like we're supposed to do for the homework?
Yeah. Yeah. So again, that portion, it will be, again, this lecture or this traverse part, it's going to take a couple of days at least to get through it. Right. So I do make it sound like it's overwhelming, but the whole point of this is for you guys to understand this big chunk there right here. Glad that you guys already understand differential leveling. Glad we're working on figuring out pacing and all that stuff, but this is going to be right here, the big chunk that we need to just get some kind of grip on to understand and to make this class a success for you guys. Right. So then the other one, and this is just an example of you ever see this in the field. You know that you're not working with a good surveyor, or you're not working with a good company, and you just need to get out. So again, we're going to call this one a geometrically open. and a mathematically open. Mathematically open as well. So again, let's say you start out with 2 known control points down here. Right. You go to another one. We call one station A, one station B. Right. And this time we're using deflection angles. We talked about that. I believe we talked about deflection angles. So again, you're running through here to your traverse points. Again, this via, let's say you're doing this via stations, right? So again, let's say we're starting at, station 0 here. And then this is station 400. Let's just make up numbers here. 8 plus 19. Station 12 plus 05. Say station plus 61, or 15, sorry. 6 plus 16. And then we'll be about station 22 plus 86. Okay, station 6. All right, so we're at the bat. What do you see wrong with this sketch? Just based off of what we've been doing earlier. We're starting out with 2 new known control points, right? Like they're those 2 maybe they did come off of GNSS, maybe they did come off of NGS, maybe they're 2, they've been established, they've been of record. But we're starting here and we're ending here. So we don't know if we're actually mathematically closing, right? So this whole thing in the real world, it could be rotated north-south from the actual true location that we could be, because we're not tying back into anything of control, right? So this whole thing could be skewed, this way, or it could be skewed this way, just off of these 2. It could pivot, right? Our azimuth can pivot because we don't know if we're actually tying into anything of record or of published data, right? So again, when you see this type of work, when you see this type of traverse, and like that, you know that there's a big red flag immediately, right?
So it's what not.
What not to do. Textbook, what not to do. Again, this was actually done via 1800s with railroads, with highways. Well, not highways, with railroads and different types of areas like that when we first started going west. Because again, you don't know what the other side is, so you're just going, right? You're just going until you find some type of hardship there. Where this practice is no longer done. So I'm just gonna say not to be done. All right. But again, this is one of those type of traverse that we don't understand how accurate it actually can be when we apply it to published data, record data, things like that. Nick?
How do surveyors go about establishing benchmarks?
Establishing benchmarks? It's a great question if you want to take GPS 450, GME 454.
Okay.
Were the measurements that they took using this accurate, or did they have to read all the data?
Well, in order to be accurate, they would have to tie into known control points.
Yeah.
So that's the biggest issue. And so that's a lot. If you went out there, you told your boss, hey boss, I'm gonna go do a traverse. You go, all right, well, what do you plan on doing? He goes, oh, I'm just gonna go set up some stations, blah, blah. You went out there, you did all this data, and then you went back to the office proud of yourself. And he looked at it and he goes, what'd you close into? or what's your, you know, how can you tell that you're accurate enough what class you meet of, you know, NGS or federal or anything out there, and you go, I don't know, I just left it open, I just set them up. So all your data is based off of arbitrary numbers because we don't have actual closing numbers. Yeah, like, well, how much time did you spend out there? 2 weeks. You're gone, right? Because I mean, again, you can't do this because it can cause a whole lot of issues going forward with any type of design, any type of construction, any type of real world city problem. So like here in College Falls, everything that you do in the city limits is all has to be done on the Oregon Coordinate Reference System. Anything you do, any type of project that you're going to do for them, they require a coordinate system. And that coordinate system, the Oregon Coordinate Reference System, and you have to you have to show those benchmarks via that you set those control points yourself via GNSS observation. You came up with some kind of established records monument, right? Subdivision or land partition, whatever have you. You came up with some kind of established record so you can orientate the survey and you can come off that those known control points at all times. Right. It's again protection for the public, protection for this industry, and protection for any type of private contractor or general public. Right. Any questions? Any else?
Is there any distance, like a maximum distance you'd go before hitting another control point to?
Well, again, I mean, with GNSS, depending on how great your measurements are or how great your equipment is, I mean, you could go miles. But with total stations as you're traversing, the max you want to go, especially depending on weather, is 500 to 600 feet. Because the heat waves, curvature and refraction, all that type of method. But again, if you are establishing control points, you can set control points, you know, from here to Doris, but that traverse is going to take you a while because taking those measurements, you can only go like 600 feet at a time, right? Turning your angles, making sure you're staying on the course. Okay. Any more questions? We okay? All right. So, like I said, I'm just trying to get you guys eased into this because come Friday we're going to start working on the field notes that we have, right? And then we're going to start working on the steps that we got to take to reduce everything. All right. Okay. Happy Wednesday. Don't forget about your midterm. Already there for you. Thinking about you. All right.
Thinking about
Have a good one, guys.
I'm gonna make me nervous.
You're making me blush.